Hello, and welcome to this video by Open Forest 4D and Open Topography. My name is Chelsea Scott, and in this video I'm going to talk about two examples of measuring the change at the Earth's surface to understand the impact of wildfires. And the two examples I'll be discussing will be in northern Arizona and Los Angeles, California. So to get you oriented, the first example in northern Arizona, we'll be looking at the Kaibab National Forest, and specifically the Cat Fire, which is here, which is just north of the Grand Canyon. And here is an example of what a fire looks like in northern Arizona. So in particular, you can see the vegetation here and the smoke that has been created from the fire. So when I look at remote sensing data of a particular area, I like to understand the who lives there essentially, and the geologic and geomorphic environment. So here we're looking at northern Arizona, and this area has extensive ponderosa pine forests. So here is an image of what these pine trees look like. So they are, yes, coniferous trees. So they are cone-bearing and evergreens. They have very tall, straight trunks, often with rusty orange bark. These trees can live for 500 years, and they are considered to be young when they are less than 150 years old. These trees prefer habitats with approximately 25 inches of rainfall per year, and in these habitats that have grass and shrubs along the forest floor. They can create an open canopy structure, and this refers to when sunlight can reach the forest floor. And wildfires are important for maintaining this type of ecosystem and supporting the biodiversity. And within these climates, the Abert squirrel thrives, and here's a picture of that squirrel. So fires are very important for maintaining the ecosystem in the ponderosa pine tree forests. So prior to European settlement, there were frequent low-intensity fires. So these fires were typically 5 square miles, and within the ponderosa pine trees, the thick bark insulated the trees from damage. However, the fires were very important for burning organic debris, the undergrowth, and shrubs. Now there are high-intensity fires, and these fires are following a century of fire suppression. And this fire suppression has resulted in 10 times more fuel for fires. So this is going to be undergrowth and shrubs that have grown to be quite tall. And these shrubs are called ladder fuels. And they're called that because they allow the fire to climb from the ground to reach the top of the tree canopy. So to reach the upper portion of that tree. And this results in big and intense fires that can be tens to sometimes 200 square miles. And here's an example of the forest following a low-intensity fire and a high-intensity fire. And we can see really the fire has a very different impact on the landscape. Fortunately, though, perspectives are changing, and people are doing prescribed burns. And these are intentionally set fires or wildfires that are allowed to burn when human life and property are not threatened. And with remote sensing data, we can measure the impact of the wildfire as well as the effort to restore these areas to the pre-European setting. So let's talk about airborne Lidar. So as I said in the video referenced earlier on remote sensing, Lidar can be collected by an airplane where it shoots out laser pulses and ultimately records very high resolution recordings of the elevation of the ground surface, as well as trees and other vegetation above the ground. So let's look at what trees look like with LiDAR. So here's Google Earth imagery showing some trees in green and the forest floor in gray. And here is a LiDAR point cloud showing that same area. And so here's colored by elevation, and each dot is going to be a return of the laser pulse, where we have a high accurate measurement of the tree structure and the ground surface. So each of these features here is a tree. And with LiDAR, we can get very high resolution recordings of that tree structure. And we can also show LiDAR images in 2D, so in 2 dimensions. This is looking at a shaded relief map, which can also be called a hillshade. And here where we see it looks rough, that is where the trees are. And the roughness is created from the different elevations within the tree. So let's look at the Cat Fire. So the Cat Fire was a wildfire that occurred just north of the Grand Canyon in Arizona in 2018. On the left shows Google Earth imagery from before the wildfire. So you can see it looks very green, and there's extensive vegetation. And we can see a canyon through here, and then hill slopes on either side. And this is the exact same area, but now we see it with after the wildfire. And so it looks a lot more gray. And this is because most of the vegetation that was here has been burned. So this is showing a very stark change in the landscape from the wildfire. And we can also use LiDAR to look at this fire. So the left shows the topographic point cloud, the LiDAR point cloud from before the wildfire in 2012. And in this case, the the ground points are colored in brown, and the trees are colored in gray. And you can see there's a lot of gray. It looks conical in shape, and this represents all of the trees. So there's a very dense tree canopy. The image on the right is collected in 2019, and this is going to be after. So here we're still looking at that LiDAR point cloud, and here it looks a lot more brown. The brown is the ground, and we also see less gray of these trees. And so in this case, we can see that a lot of the vegetation was burned by the wildfire. And this results in a much more open tree canopy where the sunlight can reach the ground. And this is going to have an impact on the heat of the area and also the biodiversity. And here we're going to be looking at topographic hillshades surrounding the wildfire. So here's Google Earth image. Here's a hillshade from before, and here's a hillshade from after. And I'd like you to look in this area, which is burned. So here it's rough, lots of trees, and then here it looks very smooth. And it's that smoothness is where we're seeing the bare earth ground, where the trees were removed from the wildfire. And we can then take the LiDAR data and make precise measurements of the amount of trees that were lost in the wildfire. So this plot here is looking at the loss of the canopy. So it's colored by change in canopy height, where the red is going to represent at least 15 meters of reduction in tree height. So where we see red, that means that a tree that was 15 meters or taller was burned down in the wildfire. So there's a lot of red. So that indicates there was quite extensive loss of vegetation in this area. And some areas that are very red, which is going to indicate that the tree canopy became much more open in the wildfire. And this is going to have a big impact on the carbon that is stored in this forest, as well as the biodiversity and ecosystem that can live and ultimately thrive here. And I'm now going to change fires, and we're going to talk about the January 2025 wildfires in Los Angeles. This work has been done by Open Topography. And here there were two main wildfires, the Pacific Palisades fire and then the Eaton fire. And it's very humbling to see the changes in the landscape, and particularly in urban areas where people live from these wildfires. So here we're looking in central Altadena, and the left is the before imagery and the right is the after. And tragically, they do look very different. And we see that many buildings and some vegetation were lost in the wildfire. And we can see this same with Lidar. So this is a topographic hillshade or shaded relief map. Again, left is before, right is after. And we can see, for example, here, it's quite flat, whereas before the wildfire, there were these buildings. And so these buildings here were burned down during the wildfire. And then with LiDAR, we can make precise measurements of these losses. So this map is showing topographic differencing. So this is going to be the change in elevation of buildings and trees and other features at the Earth's surface. So red represents a loss of elevation. So we can see where these arrows are pointing, churches and commercial buildings that were lost by the Eaton wildfire. And here we can also see a large tree that burned down due to the wildfire. And here is a natural area. This is Topanga State Park. The before it looks very green. And then after, which you can see now, looks very gray. And that changing color is going to represent that really stark and sharp change or loss of vegetation due to the wildfire. We can also use topographic differencing to look at the impact of the wildfire. So here again, we see that red represents a loss of vegetation. And this thick red line outlines the extent of the wildfire. So within this area is very red. So that represents the loss of vegetation. So vegetation that was burned by the wildfire. One of the cascading or following hazards from a wildfire are debris flows. So debris flows are similar to landslides, and they happen when rain occurs following a wildfire. And this rain, particularly in mountains, is going to pick up soil or dirt or other debris and is going to bring it downslope very quickly. And debris flows are very hazardous. For example, here is a picture of a debris flow in 2018, also in California. And we can use remote sensing data to look at the probabilities of debris flows and also to look at areas where there has been erosion, which would give us some indication of a potential future debris flow. In this map, to see erosion, we would expect or we'd look for large areas of red, which would indicate a loss of material, for example, soil surrounding a river or stream. And fortunately, in the 2025 wildfires, as far as I know, there were no extensive debris flows. So thank you for watching, and I'd like to acknowledge Open Topography and Open Forest 4D, and in particular, the work on the 2025 wildfires was led by Cassandra Brigham, working for Open Topography. Thank you for watching.